The Colville River, the largest river on Alaska's North Slope, draining over 20,000 square miles, an area equal to West Virginia. The environment's cold and harsh. Temperatures can plummet to 60 degrees below zero. Winds often drop those temperatures another 30 degrees. Every winter, the sun sets in November and will not rise above the land again until January. Yet the area is delicate, sensitive to change, and also home to man. Just miles away, the Inupiat people live in the village of Nuiqsut, a remote area of Alaska that's rich in native culture, vibrant in wildlife and marine Arctic ecosystems. The people have depended on the caribou, whaling, fishing, and other subsistence resources in the area for thousands of years. In 1994, another natural resource is discovered. Arco, Alaska finds, deep below the frozen surface, vast amounts of oil. The Alpine Oil Field, the largest discovery in the United States in over 10 years. Nearly 430 million barrels of oil are thought to lie under the layers of frozen tundra. But engineers will have to push the frontier of technology before they deliver the newly found crude oil. The Alpine project presents enormous challenges for environmentally sensitive engineering and construction. The need for innovation and attention to the Arctic habitat and logistics helps the project meet those challenges. Major projects often have a critical problem where the solution is key to the project's success. Alpine's problem is which method to use to cross the Colville River. In an Arctic environment that faces tremendous forces of nature each year during breakup of the winter ice, crossing the permafrost-bound river is a challenge. Arco and its partner, Anadarko Petroleum, enlists the help of experts with a long history of engineering innovation in Alaska. Michael Baker, Jr. The firm leads the team in designing an innovative system that moves oil, gas, injection water, diesel and fiber optic cable systems safely across the river with minimal effects to the river and its habitat. Using conventional technology like bridges or trenches drastically intrude on habitats, possibly affecting subsistence lifestyles. It's decided that horizontal directional drilling, or HDD, is key to solving one of the project's challenges. However, critics say it's never been done in this type of situation and advise against it. Project engineers will prove the critics wrong. Baker cites the advantages for HDD: low labor and equipment impact, no impact to the people of the area, no work in or over the river, and of all the options, the shortest construction time. The goal of the project rests upon the philosophy to leave nothing behind but the pipeline. Baker's relationship with Alaska started over 40 years ago. In the late 50s, with the onset of the Cold War between the U.S. and Russia, Baker is called upon to design and construct the distance early warning system across Alaska, Canada, and Greenland. Baker's next project will again push the company and technology to new heights. The Trans-Alaska Oil Pipeline. Baker's fingerprints cover the project, completing over 3.2 million man-hours in the original design and construction effort. 3 years and thousands of man-hours later, Baker's extensive engineering studies are completed and construction begins. Crews from Houston Contractors and Horizontal Drilling International are brought in. But work waits until there's a foot of frozen tundra and 6 inches of snow cover. It's winter, 1997. The massive underground oil field is 10 miles long and covers 40,000 acres. The pipeline will cross the Colville and 34 miles of tundra. The pipeline that carries the oil east to its cousins, the Cathodic and Prudhoe Bay oil fields, then south via the Trans-Alaska Pipeline. Alpine is the first oil field in the world to be developed from the start with horizontal production wells. The massive effort takes 2 winter construction seasons, lasting 4.5 months each. Access and construction is completed via ice roads and paths that vanish in the spring without damaging the sensitive tundra. Using ice roads, over 20 million pounds of supplies and equipment In addition to 12,000 tons of field modules are moved. On average, one truckload of drilling supplies and equipment is transported every 2 hours, every day, for 75 days. Attention to worker safety is also made. Innovative engineering will conquer Mother Nature as well. Inside these buildings, while still freezing, temperatures hover some 70 degrees higher than the minus 45 degrees gripping the outside. From these buildings, a 36-inch tunnel nearly a mile long and 100 feet below the surface is drilled. A welded 4,000-foot section of pipe is pulled through the completed hole to avoid in-water construction impacts. Assembly of the pipe string needs an ice pad almost a mile long, the largest ever on the North Slope. It takes 40 to 50 million gallons of water to make. Permafrost causes many challenges: wireline shorts, mud motor failures, bit wears, disaggregation of the permafrost, and casing problems. Permafrost threatens the project during the first season. Thawed soils beneath the river are bound by the permafrost soils under each bank. Despite the challenges, lessons learned speed the construction by 2/3 over the previous year. Bentonite and fresh water are used for the drilling fluid, correcting the problem for the second season. Today, with production set to begin in the summer of 2000, the Alpine project redefines Arctic river crossings. It's the first HDD pipeline under a permafrost-bound river. Nothing touches the ground but the remaining pipeline. HDD allows the crossing area to remain undisturbed. Water quality, winter fish habitat, and subsistence activity are not affected during and after construction. No disturbance or loss of wetlands occur. The future of North Slope development is enhanced as Arctic horizontal drilling proves its worth. HDD crossings are about half the cost of a bridge or a trench. By eliminating mechanical safety measures for spill containment, vertical loops naturally contain a spill, as opposed to valves and other conventional supervisory control systems. The project is developed with wildlife and the Nuiqsut people in mind. Preserving and protecting the environment is key to the project. By integrating the project, the planning, engineering, design, and construction proves to be feasible and cost-effective on the North Slope. The Colville River project meets and exceeds the environmental challenges. It completes the critical task of the overall project at lower costs than the conventional alternatives. Michael Baker Jr.'s truly breakthrough engineering for the safe and cost-effective development of the world's resources in cold regions set future benchmarks for the North Slope development in the new millennium. Today, Baker employs approximately 3,900 people in over 35 offices and on multiple projects around the country and around the world. Baker is ranked in the top 10% of engineering design firms and is in the forefront of major projects related to energy, transportation, civil, infrastructure, and the environment. Michael Baker Corporation. For more than 60 years, Baker has been working to shape the world in which we live, providing engineering, construction management, and operations and maintenance services and solutions worldwide.